Welcome to qnawire.
Alright, let's go ahead and solve this problem. So we're given a situation where g of x comma y is what z is, and that's usually what we have been dealing with, but instead of that, now we have y as a function of the other two variables, h of x comma z, and the question is asking if we want to find the surface integral, is there going to be a nice formula for this thing? So yes, we can actually figure out what the formula is going to be, and it's going to be very similar. We just need to know exactly what it's going to look like. So we're just going to go through the exact same process of how we derived the original formula. It's just that we have a function of y as a function of x and z instead of z being a function of x and y. All right, so let's go ahead and start. So because the situation is that y is a function of the other two variables, we can use the same sort of idea regarding the parameterization of the surface. So we can say that x is just x, z is just z, and now y is a function h, and h I will mean h of x comma z. Okay, it's just for shorter notation. So the parameterization of the surface can be rewritten as x comma h comma z. And to find the normal vector, we need to find the partial derivatives. In this case, it's going to be with respect to x and with respect to z. So r sub x, it will be 1. This is the partial derivative, but I will use a shorter notation, h sub x. And there's no x in there, so it will be 0. The derivative with respect to z will be 0. H sub z, 1. Now, the normal vector n, of course, is the cross product of these two. So through calculation, you will be able to get that this is h sub x, comma negative 1, comma h sub z. Okay, now we are going to write f as PQR, and then we're going to figure out what f dot n is going to be. It's quite simple. It's just multiplying the x entries, the y entries, and the z entries respectively, and then we're going to add them up. So we will have p times h sub x minus q plus r times h sub z. So that's what f dot n is going to look like. And if we use the proper notation of partial derivatives, we can rewrite it as p dh dx minus q plus r dh dz. Okay, it's just the same thing as this one, but if you want to be fancy about it, you can write it in the other notation. And finally, we just remember that this is going to be the double integral of the projection of f dot n through the area. So long story short, this is the final answer of what we're going to get. It is going to be the double integral of the projection of the expression p dh dx minus q plus r dh dz through the area. And this is going to be the other formula that we can use.